You know, our planet feels pretty solid under our feet, right? Like it's permanent. But the truth is, it's a world that is always, powerfully, on the move. Today, we're going to dive into the incredible forces that build up mountains, shake the very ground we stand on, and even create the soil that feeds us. So, let's get into it.
So let's start with a bit of a puzzle. We walk on solid ground, we build massive cities on it, we totally trust it to stay still. But we all know that's not the whole story, don't we? We feel earthquakes, we see volcanoes erupt. So what is really going on just below the surface?
And that's really the big question we're tackling here. If the Earth feels so stable, where does all this crazy dramatic action come from? How can a planet that seems so quiet produce these powerful, world-shaping events? Well, the answer lies deep, deep beneath our feet.
Okay, so the key to all this, the thing that unlocks the mystery of our restless planet, is this absolutely revolutionary idea that completely changed how we see the world. It's called the theory of plate tectonics, and it's basically the engine that drives our planet.
So here's the big idea in a nutshell. The Earth's tough outer shell, the lithosphere, it isn't one solid piece. Not at all. It's actually shattered into a collection of huge, rigid slabs of rock we call plates, and all of them are floating on a hotter, much softer layer of rock beneath them.
So how do these massive continent-sized plates actually move? Well, it all takes off with the crazy amount of heat coming from the Earth's core. Think of it like a giant pot of water boiling on a stove. That heat warms up the semi-molten rock in the mantle, causing it to rise. Once it gets near the top, it cools off, gets denser, and sinks back down. This huge, slow-motion circulation creates these powerful currents, and they act like a giant conveyor belt, literally dragging the plates along for the ride.
And get this isn't just happening in one spot. The entire surface of our planet is like a giant jigsaw puzzle made of these moving plates. They carry everything, the continents, the ocean floors, and they're always grinding past each other, pulling apart or smashing together. And they're moving at about the same speed your fingernails grow. Kind of blows your mind, right?
Okay, so now we get how they move, but let's get to the exciting part. What happens when they do? What are the real-world, sometimes dramatic consequences of all this constant movement?
It is all about the boundaries. Everything, and I mean everything, happens where these plates meet. When they smash together, they can crumple up the crust to build enormous mountain ranges like the Himalayas. And when they pull apart or slide past each other, all that built-up tension can be released in a sudden, violent earthquake.
And you know how scientists figured this all out? Check out this map. They started plotting where all the earthquakes and volcanoes were happening around the world, and they saw they weren't just random. They formed these clear, distinct lines, and those lines perfectly match the edges of the tectonic plates. It was the ultimate aha moment in geology, a total game changer.
So, you've got these massive forces, plate tectonics, building things up, creating these epic mountains. But at the exact same time, there's another set of forces working just as hard to tear everything back down. So let's talk about weathering and erosion.
And that demolition process starts with something called weathering. It's basically the process of big rocks being broken down into smaller and smaller pieces without actually moving them anywhere. And as you'll see, it can happen in some really powerful ways. First, you've got what's called mechanical weathering. A classic example is ice wedging. Just imagine water seeping into a tiny crack in a rock. Then, overnight, it freezes. And as you know, when water freezes into ice, it expands. And it does so with incredible force, pushing that crack just a little bit wider. You repeat that cycle night after night, season after season, and eventually that solid rock will just shatter.
All right, next up is chemical weathering. This is when the rock itself is actually changed chemically. Think about acid rain, for instance. Pollution in the air mixes with rainwater and makes it slightly acidic. Over time, that acid literally eats away at the surface of stone, dissolving it bit by bit. That's why you see the faces on old statues and the details on old buildings just kind of melt away over the decades.
And don't forget about life itself. This is biological weathering, and it is seriously powerful. It can be as simple as a tiny seed landing in a crack in a rock. As that seed sprouts, its roots start to grow and push, exerting this constant, slow pressure that pries the rock apart. Over the course of its life, a single tree can actually split a giant boulder right in two. It's amazing. So after weathering does its job and breaks the rock down, erosion comes in to clean up the mess. Erosion is just the movement of all those broken pieces. Forces like wind, rivers, and glaciers act like nature's transportation system, carrying all that debris away.
So just remember the simple rule: weathering breaks it, erosion takes it.
Okay, so all this talk of demolition and tearing things down sounds pretty destructive, right? But here's the twist. It's actually responsible for creating one of the most important resources on the entire planet.
And this is where it gets really personal for all of us. All those tiny bits of broken rock, when they get moved around and mixed with decaying plants and animals over thousands and thousands of years, that becomes soil. Good, rich, fertile soil. Without this whole process of weathering and erosion, we literally wouldn't have the farms that grow our food.
But that begs a really important question, doesn't it? If soil takes so long to form, just how easily can it be lost?
This really puts the problem into perspective. In the Canadian prairies, a place that feeds millions of people, over a third of its cultivated farmland is at high risk of being just blown away by the wind. That precious topsoil that took centuries to form can be stripped away in just a few seasons, turning productive land back into dust.
So, we've talked about the forces that build our world up and the forces that wear it down. But the coolest part is that they aren't separate things at all. They're all connected in one big, beautiful, continuous loop, the rock cycle.
This diagram pretty much tells the whole story. Let's walk through it real quick. It all starts with melted rock, right? Magma. It cools and hardens into igneous rock. Then weathering and erosion do their thing, breaking it down into tiny bits called sediment. Over millions of years, those layers get squished together to become sedimentary rock. Now, if that rock gets buried really deep where it's super hot and under a ton of pressure, it transforms into metamorphic rock. And guess what? Any of those rocks can get hot enough to melt back into magma. And boom, the whole cycle starts all over again. It's the planet's ultimate recycling program.
And that really leaves us with one final kind of mind-bending thought. These forces aren't just ancient history. They are happening as we speak. Our planet is literally remaking itself right now. The world we see today is just a single snapshot in a very, very long movie. So the question is, what new mountains, what new landscapes is it building for the future?